All right, what's up, class? All right, today, a little bit of a short lecture. I'm only going to be really going over one problem, and this will be the pulley with the ramp problem. How do we draw this? All right, so today we're going to be talking about the pulley with the ramp problem, but we're not going to go into too much. Uh, well, we are. We're going to go into a lot more specifics on why we solve the problem the way we do and how we want to approach any problem with the pulley, essentially. So, so we have pulley with mass 1 and mass 2, right? And I have the masses. Let's say I have the masses, but let's say we don't have any values at all. Let's pretend like we don't have the values of mass, the values of coefficient of kinetic friction, anything. We only know G is gravity, right? Let's say that. If we only have that, can we solve for X variable, right? And today I want to showcase solving for every possible variable in this actually. So we're going to solve for M1, M2, acceleration. We're going to solve for gravity. Actually, we won't solve for gravity. We'll always know that one. We'll solve for mu of friction, right? Frictional coefficient. And the tension force isn't really something we need to look into immediately. So I wouldn't be worried about that one because we use tension to solve for other things. But now, I'll go over it anyways. All right. So what do we do when we are looking through this, right? Well, when you approach this problem, the first thing you want to do, like I've always been doing, is set your axes. So we're going to do M1 axis. So M1 axis, the M1 axis is going to be diagonal, right? And obviously we have some angle, theta, right? And I want this going to the right to be positive. I want going up to be positive. Now, same for M2. Let's do the M2 axis. In M2, we have this flat axis, right? You want the x-axis usually to be perpendicular with the surface. Or no, sorry, parallel. You want the x-axis to be parallel with the surface. All right, so I want going to the right to be positive and going up to be positive. All right, cool. Now that we have that, let's go down and break out our free body diagrams. M2 and M1. Now, without any knowledge of what each variable is, we can solve this. All right, let's see. Free body diagram, M1. So M1, let's start with M1. We have gravity as a force acting downward at all times, right? We also have normal force that's perpendicular to the surface. Remember, this is the surface that we have right here, right? So that perpendicular to that surface is diagonal. And then we have the force of tension. All right, let me start labeling these. Ft, Fn, Fg. All right. Now, excuse me. Now, if we have friction, then our frictional force is up this way, Ff. Why is it that way? Because if you let go of this contraption, then the entire thing, M1, would accelerate this way, right? It would fall down. So since that's the direction of motion, friction opposes it. Friction's direction is always opposite of the acceleration or opposite of the velocity, okay? So I'd have to close my door. My dog's barking. Okay, I am back. So now we can do M2s. the force of the normal force goes up. The force of gravity acts down. The force of tension pulls this to the right because the string is on the right side, right? And there is a force of friction. Do that in green to be consistent. There's a force of friction, all right? Well, force of friction goes to the left here because if M1 is moving to the right, M2 moves to the right as well. Wonderful. Now, M1, however, has a diagonal force. So we're going to separate Fg into two components, Fgx and Fgy. All right. Well, that scrunched thing right here says Fgy. I couldn't really make it any smaller. All right, let's write the sum of the forces for both. The sum of the forces here, right? The next step is to write the sum of the forces because all we need to do is separate it into x and y. Okay? Here, the sum of the forces is extremely simple. We said right is positive, so we have Ft minus Ff equals Ma, M2A. Why is it equal to M2A and not 0 or something? Because in the x direction, it's moving side to side. It's moving to the right. Right is a side to side. All right? Now, Fy is Fn minus Fg equals 0. Why is it 0? Because the block is not moving up or down. It has no upwards or downwards component of motion. All right, now for this one, we have to use Fg equals, all right? So Fgx and Fgy equal different things. Well, Fgx equals, since we know that this is theta right here, right? If we make this out to be a box of M1, and we have theta, then the force of gravity acting upon it, that means that this angle is also theta, right? So the opposite is the x, so it's Fg sine theta. The adjacent is the y, so it's Fg cosine theta, or y. All right, so let's do this one. Sigma Fx and sigma Fy. Okay, sigma Fx in the x direction. Remember that the x direction is this diagonal, this side to side. All right. So since going to the right is positive, it would be Fgx minus f of t, also minus f of f, equals ma, m1a to be precise. Sigma Fy, we have f of n minus Fgy equals 0. Why does it equal 0? Because m1 is not flying in this diagonal direction, up or down, right? You just tilt your head and then it becomes up and down. All right, so we have all this, and I want to solve for m1, m2, a, mu f, and ft. Well, essentially, I'm going to start with a. I'm going to start by solving for a. Where do we see a? Well, a is right here and right here. Cool. All right, so how are we going to solve for this? Well, simple. I want my answer in terms of the M1, M2, A, mu F, and G. That's what I want my answer in terms of. On an exam and quiz question, Mr. Cho will say solve in terms of M1, M2, A, or G. Right? All right, so we have it here and we need to solve for all these things. So we can solve for f of t in the x directions. So ft equals m2. Let me just indicate to you guys which one I'm using here. I'm going to use this equation. Ft equals m2a plus f of f. All right, I'm going to do the same thing here. Ft equals fgx minus f of f minus m1a. All right. Now you can set these two equal to each other. Remember, we have substitution on our side. So ft sub ft, so we have m2a plus f of f equals fgx minus f of f minus m1a. Great. Now, this is about the time where Mr. Cho would say, okay, stop. Let's fill in the values for things like f of f, fgx, and f of f. Because we have two f of f's now. This is too confusing. Well, on this side, let's split it up. On this side, this f of f corresponded to this f of f, right? So it's based on m1. That means that, okay, let me take a step back. Actually, all right, this is a good time to take a step back and just say, let's plug in for f of f before we substitute everything. All right, so you didn't have to erase that, but I'm going to write it to the side. So this f of f, this green f of f here, is equal to f of n times mu k, right? And we know that f of n is equal to, here it's equal to fgy, which fgy is also equal to fg cosine theta. So that means that f of n, in this case, is equal to m1g cosine theta. So we have f of f equals m1g cosine theta times mu k. Let's sub that in. Ft equals fgx minus m1g cosine theta mu k minus m1a. All right. If you don't follow along on any of this, just remember to rewind and take a small step back. All right. So fgx, however, we know that fgx here is equal to fg sine theta, which is equal to, so ft is equal to m1g sine theta minus m1g cosine theta mu k minus m1a. Okay, seems very complicated, but this is the important part is we have all our variables. I'm just putting it out there. If I give you this kind of problem on a quiz or exam, your notes are available. So you can look straight at the derivation. F of t equals m2a plus f of f. Ooh. M2a plus f of f. So that means that f of t is equal to m2a plus what's f of f on the left side? What's f of f on the left block? It's just simply going to be mg times mu k. M2g rather. M2g times mu k. All right, now let's set these two things equal to each other now that we've plugged everything in. I'm going to do it in blue. M2a plus m2g times mu k, that's this part, and I will do this part in green, equals m1g sine theta minus m1g cosine theta mu k minus m1a. Now, it might look really long and perplexing, right? But how did we get here is important. We essentially, the reason we got to this huge equation is because we solved for f of t, right, in both sides, and then just set them equal to each other, all right? The long part comes from solving and substituting f of f, like force of friction, right? So now, let's solve this out. How do we solve it? How do you solve for a? Well, you solve for a in these scenarios with one simple algebra technique. And it is to put the a's on one side. So I see an a here and an a here. I want to put it to the left. So plus m1a plus m1a, right? I'm also going to subtract m2g times mu k from this side. And likewise here, I'm going to subtract m2g times mu k here, right? So let's rewrite it. It's m2a plus m1a equals m1g sine theta minus m1g cosine theta mu k, should write this k lower, mu k, all right, minus m2g mu k. All right. Now we just distribute the a to obtain a m2 plus m1 equals all that. I won't rewrite it, so I'm just going to put the double apostrophes to say it's the same thing. Then we divide both sides by m2 plus m1 quantity. 2 plus m1, right? And we obtain the answer, which is a equals m1g sine theta minus m1g cosine theta mu k minus m2g mu k divided by m2 plus m1. Super long answer, I know. It's very confusing, perplexing, complex. All right. A lot of you had trouble solving for mu after this. Well, solving for mu is also no big deal. Personally, I would just start here. If I wanted to solve for mu, I could start here. I could also start here. I would just have to unravel some things. All right. But Mr. Cho is going to start here. All right. So let's see. Let's take this down here. Undo that. All right, I want to move that down. I'm going to move that one down. I'm just going to copy paste it down. All right. So let's start from here again. Now we're solving for mu. Come on. Oh, that's right. There we go. Okay, now we're solving for mu. Where's mu? Mu is here. We have mu k here, mu k here. Cool. What do? We put mu on one side. That means we subtract m2a from this side. So subtract m2a. And then we add m1g cosine theta. That was oddly written. Cosine theta mu k. And we add m1g times mu k, oh, cosine theta. Cosine theta mu k here on this side. We rewrite everything. So we have m2g mu k plus m1g cosine theta mu k equals m1g sine theta minus M1A minus M2A. Okay, and then simply all we do is distribute the mu k. So we, in essence, our answer becomes mu k times M2G plus M1G cosine theta equals M1G sine theta minus M1A minus M2A. So to solve for mu, you divide both sides by M2G plus M1G sine cosine theta. So what the solution for mu k is equal to M1G sine theta minus M1A minus M2A divided by M2G plus M1G cosine theta. All right, that's about where I'm going to stop. All right, why do we do it with these complex variables? Because if Mr. Cho gave you M1 equals 12 kilograms or something like that, and then you could just plug 12 kilograms into M1 here and here and here easily. If you knew the angle, you can also just plug it into this angle where theta is. G, you can plug it in as 10 every time, anytime. All right. So that's the important kinds of things we need to know. So now that we have established that and I've shown you how to solve something, here I will extract the equation once more. And for your bell work problem or daily check-in problem, I want you guys to take this equation, solve for M1, right? As in get M1 by itself. And then I will give you everything else. A equals 5 meters per second squared. M2 equals 10 kilograms. Mu equals 0.2. And theta equals 37. All right, given all this information, solve for M1. That is simply it. All right. So I hope you guys have a great time. Tomorrow is your quiz, so we will talk about that. Regarding, well, we're not going to talk about it, rather. I'm going to post it tonight, and you have all day to finish it. All right. The lectures that it will cover is all of dynamics up till today. So make sure you study for the quiz. Have a wonderful day, guys.